This is Darrell Jones for the cloud computing video that we could get extra credit on, just to discuss um, the future and what the video was actually describing as what's going on and what's on the horizon for cloud computing. Basically, what I got out the video was that they're trying to take the actions that typically happen in the network between two nodes, two computers, one on one network, one on another, and that's where they're trying to put all of the functionality instead of having the functionality actually occur in the lower parts of the OSI metal, mainly the networking and the physical layer. It has its advantages. If you cram most of the functionality uh, going up the OSI model into the application layer, that's going to be on two separate computers. So what that's going to do is going to free up, uh, it's going to make performance go up, and it's going to free up resources. Because the network, the physical devices, as in your routers and your switches, won't have to be bogged down with all that functionality. They can basically just do what they were designed to do when they were first invented, which is to transport data and get them to the destination. And it also has a second advantage in that um, the price of your networking equipment will go down. If you don't have all that built-in functionality into your routers and switches, the prices of them will either just level off, or in some cases may even decrease. When you start adding in extra functionality and designing components for extra functionality into the networking devices, you're going to pay for it. It's going to go up. And what they were describing, I think it really is um, the future to where networking is headed, because ultimately you're going to get a bottleneck somewhere. Now, uh, you know, bottleneck. It really depends on how your network is designed, uh, and what it seems that this could possibly do is to keep the network from bottlenecking. If you're putting all the functionality on your end nodes, then you're going to have more flexibility in your bandwidth to transport data. Uh, this is pretty much evident because there is somewhat of a trade-off, and you're going to pay for it. Uh, Businesses are starting to do this as well. You have to pay for the actual use of their network. If you don't have, like, for instance, a cell phone with an unlimited data plan, you have to pay every time you send a text message or a picture or a video, and basically you're just paying for the amount of bandwidth you used on the network. I don't know what the going rate is, but some companies charge like per kilobit, per megabit. I don't know what it is, but more and more you're seeing more companies start to do that. And the functionality is built on your cell phone, which is another example of an end node. All the functionality is on the cell phone. You select the picture, you make the video, you do whatever function you're trying to do, then you send it over the network, and then it gets to its destination by a host of routers and switches. Um, I think this is a better way for freeing up resources. Um, Basically, let it be the end nodes problem and let the applications fight it out. Uh, Whichever application, however your setup is, applications they will go into a queue, a queue, and they will actually bid on resources. And this keeps the network less congested, and it gives the user more ability to really um, to build in the functionality that he wants. It's taken basically it's taking the power from the lower end of the stack and giving it to the higher level of the stack, which is the application layer, which is the layer that the user mostly interacts with. When the user has most of the power and can make the decisions about what devices or which resources are going to be used, it's easily changed. And basically, the user knows better what he wants and how he wants the network to flow, instead of leaving it up to a device, or more in a more complicated setup, a global dictator in the computer. And this is really like a controller or some type of device that kind of senses everything that's going on in the computer and tries to dictate as best as it can, but it's still mechanical. It's not human. It doesn't have the human touch that's needed to fine tune and tweak. Best case scenario, it will make the best decision it can and go with it. But um, I enjoyed the video, and I do think that more and more as uh, we get accustomed to sending more data, the amount of data that we send is growing exponentially. Um, the types of data that we're sending, you know, videos, pictures, things of that, it's just going to keep going up and up. And as computers and network technology keep advancing, the amounts of data that we're going to be sending is just going to continually increase. I don't know if the networks currently, I don't know if the network architecture that we have in place can keep up, but um, by shifting everything to the application layer, I think that will take a big bite, or at least kind of speed things up until network architecture can keep pace. But I like the video. I think that's the way things are headed, and we'll see. We'll see if this model of cloud computing really takes a stronghold. I believe it will.